In this task, we have to familiarize with all the settings and functions of an oscilloscope and a function generator. First, let's start with an oscilloscope. Oscilloscope contains three main functions. First function or system is the vertical system controlled by these knobs. Then we have the horizontal system controlled by these knobs. And lastly, we have the trigger system controlled by these knobs and buttons here. In each oscilloscope, you will find a label saying vertical, horizontal and trigger for the three systems. Vertical system allows us to adjust the waveform vertically in the amplitude. The big knob adjusts the scaling and the small knob will adjust the position. And similarly, you have for channel 1 and for channel 2, because this is a 2-channel oscilloscope. If you have a 4-channel oscilloscope, there will be 4 sets of knobs. Similarly, for the horizontal system as well, we have the big knob to control the scaling and the small knob to control the position of the horizontal waveform. Then we have the most important function or the system, that is the trigger system. This is usually in digital oscilloscope not very touched in the initial stages, but this is what makes the waveforms still and readable in the oscilloscope. The trigger function basically aligns a trigger so that your waveform is displaying still in the display. There are different types of triggers. You can have edge trigger, and edge trigger also you can divide it to rising edge triggers and falling edge triggers and many more other functions. Let's look at that in the later videos. To turn on the oscilloscope, you just need to press the power button and then the system will start. The three systems that I first indicated, the vertical system, horizontal system and trigger system, they might look a little different depending on the brand of the oscilloscope. However, their functionality and these knob patterns will remain the same. So even though you have a different brand, you can check for the vertical, horizontal and trigger systems. The functions will be the same. Now, this is the initial display that you get in the oscilloscope. Now, the important thing is, this is how the previous person left the oscilloscope. So that might not be ideal, because sometimes they have changed some settings, sometimes they have enabled or disabled certain functions. So first of all, when we start a practical, we want to ensure that the oscilloscope is in its default state so that we can continue with our practical without any issues. So to ensure that this is in the default state, you have to press a button. That button is called the default button. Again, that button will differ from brand of oscilloscope. For example, here there is a single button for default setup. So when I press that, the screen should reset and it should come to the default setup. Sometimes this default setup button or the setting will be buried inside some other function, so you need to refer the manual of this oscilloscope to find out where the default is. After getting it to the default setting, this is ready for your measurements. First of all, what you need to understand is, oscilloscope is an input device. It is an input device where it can take in signals and display. This can't produce signal, or we are not using it for that purpose. So for the testing purpose, there are some calibration ports given. So if you see in each oscilloscope, you will get some ports like this. These two ports produces a set waveform at a specific frequency and amplitude. Using these calibration ports, you can display a waveform and verify that the result is accurate. This is the basic overview of the oscilloscope. Once again, three functions: vertical, three systems, vertical system, horizontal system and trigger system. And this is all to do with the settings inside the oscilloscope, and once we progress towards certain tasks, we will explore these functions further. Lastly, I want to explain a little bit about the connector of the oscilloscope. So in the oscilloscope side, we connect this right here, this is actually called a B and C connector. So this is a common connector you can find in satellite systems and your CCTV cameras and etc. So what you can do is, so there are two channels, two inputs. So I will insert it to the first channel. What you need to do is you need to push it in, then you need to rotate in order to lock it. So after that, no matter how hard you pull, it will not come off. And then in the other end you have these two right here. So first of all, you have a probe, that it's essentially a probe, and you can retract it using this lever, and you can attach this point to your test setup. So any pins, any components, you can attach it. And this crocodile connector is essentially your ground connector. So it is very important to first connect your ground to the system and then connect it to the system. So this is basically the ground and this is the positive. This is where you should connect the you should have the signal coming into this probe, and this is actually detachable, so you can remove it and you can use this pin as well if you can't clamp it or if you can't hook it. So you can just remove this and you can use this pin. And also there is a small selector button here, and it says 10x and 1x. This is essentially the scaling factor. Basically you can have it scaled to times 10 or times 1. In this initial stage, ideally what we want is to have the exact same readings as the signal that we are inserting. For example, if we are inserting 5 volts, we should be able to display 5 volts instead of 50 volts. So that is what this selector knob does. Again, we can take a look at this in more detail once we progress towards the practicals. So this is a brief overview of the oscilloscope.